Hello everyone, welcome to the introductory unit on techno-economic analysis in green engineering. In this first unit, we will cover the basics of techno-economic analysis, or we call the TEA, which combines the technology performance with economic considerations to guide green engineering decisions. We will begin with the introduction to the concept and then move through our course syllabus. Later, we will take the learning curve model as an example to showcase how the TEA applies to green technologies. As we navigate toward net zero emission, our approach must be twofold: assessing the technical feasibility and ensuring economic competitiveness of our green technologies. First, technical feasibility. It is crucial to understand the capability of technologies like solar, wind, not just theoretically but also in practical terms. These include their integration into the existing energy system, addressing the grid compatibility and efficient energy storage solutions. Second, economic competitiveness. Our objective is to make green technologies not only sustainable but also economically viable. They should provide a cost-effective alternative to conventional energy sources in order to foster widespread adoption. So, what is TEA really about? TEA is a method used to quantitatively evaluate and balance the cost and benefits of various technological systems. The objective here is simple but profound: to provide a clear, objective assessment that helps us to see beyond the initial cost to the long-term economic benefits of sustainable technologies. It is all about ensuring our solutions are not just technically feasible, but also economically sustainable. When we look up the TEA on Google, the very first result leads us to the US Department of Energy's page on techno-economic analysis. This is not just a coincidence. It shows that the TEA plays a crucial role in the energy planning and the policy making. As we know, energy is at the heart of our green transition. It is a significant area because 3/4 of the global carbon emissions comes from our energy use. This massive contribution to global emissions highlights just how critical our energy decisions are. Let's consider the extensive body of academic work available nowadays. If we search for TEA on Google Scholar, starting from the year 2020, we find 40,700 academic articles. But when we narrow this search down by adding energy to TEA, the number slightly decreased to 40,200. This shows us that nearly 99% of all the techno-economic analysis research is about the energy topics. This signifies the critical role that the TEA plays in our energy transformation. TEA is not just about analyzing cost and benefit in isolation. It is about integrating this analysis within the context of energy system, highlighting how crucial this tool is in developing and refining the green energy technologies. Let's take a look at our course module syllabus. First module, TEA overview. This module provides an introduction to techno-economic analysis. We have already discussed why TEA is crucial in evaluating new technologies and their market potential. As a case study later, we will analyze the learning rates of green technologies, which is fundamental to understanding how the clean technology improvement over time. For the second module, time value of money. In this module, we delve into the time value of money. We will discuss how financial elements such as payment, discount rate, and the time period influence the monetary value of projects. A practical case study will be feed-in tariff, selecting solar as an example to understand how these incentives are designed. For the third module, we will focus on economic feasibility analysis, covering payback periods, present worth analysis, annual worth analysis, rate of return analysis, and the benefit cost analysis. All of these tools help us not only evaluate the viability of projects, but also helps compare different investment options over their life cycle. We will introduce the key concept of levelized cost of energy, LCOE, in our case study, which is critical in energy project assessment. For the fourth module, System Thinking, Carbon versus Cost. In this module, finally, we will apply the system thinking to the complex relationship between carbon emissions and the cost. We will use life cycle assessment, LCA, and the total cost of ownership, TCO, to evaluate the trade-off, particularly looking at electric vehicles or scooters. I look forward to engaging with you throughout this course, and I'm excited to see how you apply this concept to real-world challenge.